Welcome back. Let's quickly discuss how to debug with Python and also how to use the built-in datetime library. Python comes with a powerful debugger that can help you find mistakes in your code. We can set a trace that allows us to essentially stop our code at any point, hold it on pause, and then decide and explore variables and operations. We're also going to discuss Python's datetime capabilities. Let's load up a notebook and see how these libraries work. Let's imagine that we have three variables, x as a string 1, y as an integer 2, and then z as the integer 3. And maybe later on you have hundreds of lines of code, and somewhere along those lines you say result is equal to y plus z, and then you print out the results, and then a couple hundred lines down you say, okay, result is equal to y plus x, and then you get this type error. And maybe you get another error that you really can't interpret. This one's a little easier to interpret. It says integer plus string, so you know one of these is an integer and one of these is a string, but maybe you're also having trouble telling which is which. So if you have hundreds of lines of code, it's going to be really hard to try to find where your error is occurring. And in order to solve this issue, we can initiate a trace using the debugger module. So to do this, the first thing we need to do is import Python debugger, or PDB. And then let's set up the situation again. So we'll have x equal to this one string, y equal to 2, z is equal to 3, and then let's just say there's lots more code here, so hundreds of lines, and then we'll say result is equal to y plus z, and then we print out the result, and then somewhere along the line we have a lot more code, so more and more code. And then we're going to set a trace here. We say PDB, and then we call the setTrace method, open and close parentheses. And then you have lots more code. And then we'll say new result is equal to y plus x. And then we're going to print that new result. Let's make sure that's an underscore. There we go. Let's take a look at what we have set up here. I have my three variables defined. We can imagine there's lots more code. I have some sort of operation, and then I have lots more code, and we're going to comment out this set trace for right now. Then we have lots more code, and then we try new result and print the new result. If I run this cell, I get some sort of type error, and it tells me, hey, your type error is happening at this line, line 17, where you're having a new result is equal to y plus x. And I'm getting this type error, but maybe I have so much code here that I'm really unsure what y is and what x is. And when you're starting off programming, what you sometimes do is, in order to debug, you just print out maybe type of x over here, and then you print out type of y. And this is a way for debugging for beginners, since they need to print out a bunch of statements and see what is actually what. So then when they run this code, they see, oh, it was a string integer. They look back and they say, oh, x was that string, so that's the problem. However, it's much easier to use a trace. So we're going to uncomment this line and have Python debugger set trace. And what this does is it runs all the code above that trace command and then allows you to pause and have an interaction with a Python shell. So we're going to run this, and here we can see the Python debugger, and now I can type variables out as if they were already defined in a shell. So I can type in x, and it gives me back x, and I can see here it's a string. Or I can type y, and it gives me back 2 here. Or I can say, what is the type of x? Hit enter, and it tells me class string. And this is a much easier way to play around with your variables and check what's happening. And you can even do operations here. You can do something like z plus y, hit enter, and it will tell you the result is 5. So you can both check variables, do operations, all as if you had a Python shell opened right in the middle of your code. This allows you to interact with the variables that you've already defined instead of having to add in a bunch of print statements. And it saves you a lot of time because now you don't need to search your code and kind of discover where the problems are. Instead, you can interactively set a trace and then work with your code there. And when you want to finally end this, you can just type in quit, and it will quit the Python debugger. So that's how this works. You can see we have the kind of quick command, but it allows you to set a trace and then play around with all the variables as if you had a shell open there. Now there's a lot more functionality for the Python debugger, but definitely the one you're going to be using the most is this set trace functionality. So keep it in mind next time you find yourself having a bug that's hard to find. Let's now discuss datetime objects, and this basically just shows you how to work with basic dates and times in Python. In order to create a date or a time, you need to import the datetime library. And then you can say something like t is equal to datetime.time, and then you pass in the hour, and this is a 24-hour clock, the minutes, 15 minutes, and then we can even pass in seconds. And if you want, you can even pass in microseconds, but we won't do that for now. So we can show you what happens when you don't pass them. And you have this datetime object, so if you say type t, it's this datetime.time object, meaning that it's indicating a time. And we can grab the hour off of that time, or the minute, or the second, and you can even grab microseconds off of this. If you don't define the microseconds, when you created this datetime object, it'll just default to 0. And it's the same for not defining seconds. So if we were to take off the second and then rerun this, it would end up saying seconds is equal to 0 and microseconds is equal to 0. If you want to get the current date, then you can use a date object. So that's going to be similarly datetime, except instead of saying .time, you will say .date. And then if you want, you can define a date using year, month, day. So you can do something like 2018, month is 10, day is 11, and then you have this date object. Or if you want today's date, you can say datetime, date, and then say today, run that, and that will grab the date off of your computer's operating system. So it'll say 2018, January 18th. And if you want the date time, that is both the date and the time, we can say datetime.datetime, and then say now, and that grabs both the date and the time information. So here we can see the date information, and then here's the time information. Hour, minute, second, and then microseconds. So there's both time objects, which is just the time. There's the date object, which is the month, the year, and the day itself. And then there's datetime objects, which is both the day and the actual time. So let's quickly show you an example of how you could time your code, because most often you're going to be interested in using this library if you're trying to figure out what's the most efficient way to do something. And the way to do that, let's say you had a list comprehension saying result x squared for x in range, and let's make this a larger number, we'll say 10,000. So I want to know how long did it take to actually create that result. What I can do is create an initial timestamp, t is equal to 0, and say datetime.datetime now, and then right after we run result, I'm going to say t1 is equal to datetime.datetime.now. And then what I can do is say that the difference is equal to datetime at point 1 minus datetime initial at t0. And if I check out my difference object, this DIF, I can check out the microseconds, and it took a total of 4,014 microseconds for this result to run. And if you check out seconds, it's going to be 0 because it's not a long enough time for it to actually measure it out in seconds. So it only took, in this case, 4,014 microseconds. Now this number may be different depending on your computer, and if you make this number too small, for example, if you just make it 10, this is going to run so fast that it's likely your computer won't be able to actually catch how fast it did it. So we're going to run this and see if we can catch the difference. And it looks like it was 502 microseconds. So keep in mind, depending on how fast your computer is, if this number is too small, it may just say 0 here. In my case, my computer was able to catch it because it took some time. But that's something to note. If you're having really fast operations, it won't really make a difference timing them. Instead, you can run them multiple times. And this diff object, if we check it out, it's a time delta object, which is essentially just the difference between two datetime objects. And that's really it for the datetime module. So as a review, off of datetime, you have time objects that you can create, which indicate hours, minutes, seconds, and microseconds. you have date objects you can create, which is years, the month, and the day. And then you have date time objects. And a lot of people tend to work with date time objects because if they don't want the time information, they can just default it to 0. So we have the year, the month, the day, and then hours, minutes, seconds, microseconds. And this allows you to quickly time your code so you can test which block of code is more efficient. We'll see you at the next lesson, recruit.